think and I hope I set everything up properly. Welcome back. If you don't know who I am, I'm the Duke, uh, which is just a pseudonym. But basically, I'm trying to go through the book, build your own Lisp, and learn as I go, and I don't know, share my knowledge gained with whoever watches this, if anyone watches this. But actually, I got 12 views on my live, which is a decent number. Without further ado, I don't want to say anything else. Let's start. Just one more thing before we continue. I noticed in the last video that there was a loud humming coming from my computer because I don't think it can take the amount of processing it's like, or maybe it just ramped up the cooling fans. But basically, I think I enabled a noise processing filter on OBS. Oh, OBS is amazing. So I think everything is okay now. And we'll start shortly. Okay, so let's do this. Let's do this. Let's do this. Okay, so let's continue. Where we stopped? We stopped at chapter 4. The chapter 4 is called an interactive prompt. Let me just change the color of the pen. Maybe green. Okay, green is okay. So this is the 4th chapter, and the sub-chapter says read, evaluate, print. As we build our programming language, we'll need some way to interact with it. Okay, C uses a compiler where you can change the program, recompile, and run it. It would be good if we could do something better and interact with the language dynamically. Okay, then we test its behavior under a number of conditions very quickly. For this, we can build something called an interactive prompt. This is a program that prompts the user for some input, and when supplied with it, replies back with some message. Using this will be the easiest way to test our programming language and see how it acts. Okay. This system is also called a REPL, which stands for read, evaluate, print loop. It's a common way of interacting with a programming language which you may have used before in languages such as Python. Okay. Okay. Before building a full REPL, we'll start with something simpler. We are going to make a system that prompts the user and echoes any input straight back. If we make this, we can later... Okay, so, I mean, these are the basics of development, of programming. A simple input-output flow scenario in which you, I don't know, input something, and the terminal prints it back to you. So I think we'll skip it unless there's something really interesting to learn or unknown to learn. Okay, an interactive prompt. For the basic setup, we want to write a loop which repeatedly writes out a message and then waits for some input. To get user input, we can use a function called fgets. Okay, fgets. Let's remember fgets. which reads any input up until a new line. We need somewhere to store the user input. For this, we can declare a constantly sized input buffer. Okay. A lot of new terms here. Let me just maximize this. Maybe it's more helpful. A lot of new terms here. Are these explained anywhere? Are these? Let me just remove this. Are these explained anywhere? So what do we have here? Declare a buffer for user input size 2048. Okay, this is a buffer. This is the main. Okay, I don't need this. Okay, it prints out this, prints out it. While we are in a never-ending loop, f puts this, f gets this, and then prints again. Okay, the comments. Okay, let's go over this program in a little more depth. So, the first line. Static char input 2048 declares a global array. Sorry. Declares a global array of 2048 characters. This is a reserved block of data we can access anywhere from our program. In it, we are going to store the user input, which is typed into the command line. The static keyword makes this variable. The static keyword make this variable local to this file. Okay. And this is the size. I still don't grasp it properly, so let me just do this, come here, do this. Okay. Static car input 2048. This is a snippet in the C programming language. Can you explain me in simple terms what the static does and what the size section does? 2048. Okay. Okay. So what does it here? A car input of size 2048, it specifies that this is an input. It's an array of characters. A character is 1 byte of memory, and this can hold 2000. So basically, this can hold 2048 bytes, right? So basically, it means that it can hold 2048 bytes, right? Okay, okay. And the static, what does the static do? In C, the static keyword has different meanings depending on the context. Here, what it does, variable declaration. So it's not inside a function, it's outside of, it's at file scope, yeah. If static is used outside of all functions at the top level of a file, it means the variable is only accessible within that file. Okay, only in this file. It's not visible to other files in the same program. Okay. And this is useful for, okay, this is just an encapsulation mechanism in C. Similar to, I assume, the privacy keywords that exist in other programming languages. This is a static variable, and we have 2048 bytes. Okay. I think I understand this now. Shit. Let me just. Oh, sorry. I thought my string was broken. Let me just get the pen again. and remove this guy. Okay. We write an infinite loop using while. In a conditional block, one always evaluates the true, so it's basically a loop that never ends. To output our prompt, we use the function fputs. This is a slight variation on puts, which does not append a new line character. We use the fgets for getting user input from the command line. Both of these functions. Okay. Standard input, standard output. How am I meant to know about functions like fgets and printf? If it isn't immediately obvious how to know about these standard functions and when to use them, of course you need experience. But luckily C has a very small standard library. Okay. So I mean it's simple enough, but maybe it's not bad to run it, go over it. Okay, let me just open a new window. Increase the size a bit. Okay, where are we? We are here. Let's go to projects. Let's go to build your own Lisp. No, not in code. I'm gonna open it in Vim. Okay. What I want here, I want to remove the file. Introduction to Lisp. How to remove the contents of a file. Vim. I don't. Why does it? Why does ChatGPT every time I request something regarding Vim displays the full list of steps, including, you know, open the file. I know how to open a file name. Okay, GG, DG. Okay, GG, DG. Simple. What do we say? Include standard input output. Let's declare a static character. Okay. Maybe I wasn't supposed to delete all of them, but okay, no worries. Int argument count. This argument vector. Okay, I'm just gonna do the while. So I'm requesting fputs Lisp standard output fgets input this standard input this no Jura s input this, let's return something, this shit, this, and hello world. Okay, no compiling errors. Test 2 working. Idiot. Okay. Let's close this. How can I close this? Okay, Control C. Two things that I just want to quickly understand before we move on is hello world.c is what does this guy do, what fgets does. Okay, what do these 2 lines of code do? Okay, no, I didn't want to do it. Can I stop it? I have to stop it. I want to ask these questions in the thread for the C programming language. Okay. So what fputs does, it's a standard C library function used to write a string to a file or output stream. In this case, we are using the standard output, which is, I assume, the terminal of our text editor, right? I assume so. Okay. This is the string that will act as a placeholder, I assume. This is the standard output, which is usually, yeah, the terminal or the console. And what? Okay, this is pretty simple. The syntax was giving me head confusion at first. Okay, now the fgets. This is a standard C library used to read from a file or an input stream. Okay. Okay, it will be stored here. And this is the maximum number of characters. So it has a limit. And if we extend this limit, I assume we will overflow the stack. I assume. Yeah, so it will read up to 2047 characters plus the null terminator. And it reads from the keyboard. This line waits for the user to input a string and then stores the input string in the input array. The input includes Okay. This goes to standard output. Then we print. It goes to standard input. Okay. Yeah, I took 17 minutes to grasp this. I'm an idiot. Let's continue. Okay, we are compiling this. Oh, it's not hello world anymore. No worries, we can remove it. You can compile this with the same command as was used in the previous chapter. After compiling this, you should try to run it. You can use, okay, I already know this. Editing input. If you are working on Linux or Mac, you notice some weird behavior when you use the arrow keys to attempt to edit your input. A, B, C, D. Okay. Using the arrow keys is creating these weird characters rather than moving the cursor around in the input. What we really want is to be able to move around on the line. On Windows, this behavior is the default. On Linux and Mac, I'm using Linux. It is provided by a library called editline. And we need to replace our calls to fputs and fgets with calls to functions this library provides. So what I assume will happen here is we will use this library called editline, and we will most probably provide editline to fputs and fgets using editline. The library editline provides 2 functions we are going to use called readline and add history. The first function, readline, is used to read input from some prompt while allowing for editing of that input. And the second function, add history, let us record the history of the inputs. Okay, first things first. Make directory hello world. Make why? The file. Okay, I'll just create a new file maybe. Makadir. No, let's do this. Chapter 03. Move hello world to chapter 03 and move hello world to chapter 03. And this is chapter 04. And I want to copy from chapter 03 our hello world to chapter 04, and I'll name it whatever. Input output. No, not this guy. I want to do this guy and move it to chapter 04. Input output C. Is this working? Yes. Okay. Let me just increase the size of the terminal window. We replace fputs and fgets. So we don't need them anymore. With calls to these functions to get the following thing. Okay, these are just comments. I don't need them. So the only thing I need is the while loop. Okay. Clear vim. Input output. What do I need to do? I need to include standard library. Vim. Move to the start of the line. How? I'll remember this. I only need these informations once, and I'll remember them later on my own. 0. No, it's not this. Is this? If I press the big guy. No? Okay. Okay. And how do I move to the end of the line? How to to the end of line, Vim. $sign. Okay. Include edit line, read line.h, include edit line history.h. It seems that I don't need the static character array anymore. How to remove a line in Vim. DD. Okay. DD. Let me just, so the $sign moves to back and the 0 moves at start. Why? No idea. Let's move it here. So what am I doing here? $sign. Okay, I can remove all these, right? How do I undo? Undo in Vim. Okay. Removing this line. Removing this line. Let's leave this one. And let's input. So this is a character pointer to the input. It says read line Lisp. Okay. Add history input. This is okay. I already have this, and free input to this. Okay. Fuck. No such file or directory. Why? Why? Why am I missing input output? Edit line. Read line H, edit line. I should have this, right? I should have this. I should have this, right? I need to why do I need to install some packages? Okay, let me ask my good friend ChatGPT here. What to do when I encounter this error while compiling my C code? Okay. Okay, so we need to install some packages. Why we don't have them built in beats me. So this is the edit line and this is the read line. Okay. Include edit line, include read line. Will this fucking work? I hope so. I hope so. I can close this guy and try to do everything again. Why? 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 We have include okay, let's continue reading the book. I think we have included a few new headers. There is include standard library, which gives us access to the free function used later on in the code. Okay, thinking ahead, I like this. We have also added include edit line and include edit line, read line and history. And instead of prompting and getting input with fgets, we do that in one go using read line. Like this. And why is it a character pointer? No idea. Maybe it will tell us. Unlike fgets, the read line, it strips the trailing new line character from the input, so we need to add this to our printf function. Okay. I need to add a new line here. That's something that I completely missed. Let me just change the language here. Sorry, the color to blue, pinky. Unlike fgets, the readline function strips the trailing new line, so we need to add this to our printf function. We also need to delete the input given to us by. We also need to delete the input given. Where the heck's free? I have it here. Okay. Okay. So fgets, which writes to some existing buffer. The readline function allocates new memory. Okay, yeah, that's why we had to declare a static array character for fgets, but the readline allocates new memory when it is called. And when to free memory is something we cover in depth in later chapters. Okay, not needed for now. Okay, let's see how we compile with edit line. No such file or directory. Yeah, I had the same error. Lib edit dev. Have I? Oh, have I? I have lib edit dev. Okay, I have lib edit dev. I have lib edit dev. And now if I run this again, if I try to compile it, it says here, once you have installed edit line, you can try to compile it again. This time you'll get a different error. Wow, Daniel is the genius who wrote this book. Daniel knows what errors I will get in advance. Okay. So yeah, we have these two errors. This means that you haven't linked your program to edit line. What does this mean? This linking process allows the compiler to directly embed calls to edit line in your program. So I need to add a flag to the compiling process. No. It's because it's here, right? Okay. Wow. Simple enough. Run it and check now you can edit input as you type them in. Okay. It's still not working. Some systems might have slight variations. Okay. Okay, I don't need this because I already installed it, most probably. Okay. Before we continue, before we go any further into the abyss, I want to do something. I want to analyze what is written here. First of all, input output test. No, you are a test. Okay, yes, this is because I need to add a new line. Vim input output.c. I need to add a new line here, like this, right? Yeah, right. Test. You are a test. No, you're a... Okay, still doesn't work. Vim input output.c. It's the other character, yeah. Test. Test 2. Idiot. Okay. I agree. Yeah. Okay, before we continue with the C preprocessor, get input output.c. I want to understand some of this code better, because if I understand it now properly, considering that I haven't done any real programming in C, I don't know, well over 6 years since the university, you know, I just don't want to come to the next steps of writing our own Lisp implementation and suddenly thinking, wow, this is complex, but I don't even know what it was built upon. So no, 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 no. No, I didn't want to do this. Yeah, I wanted to go here. I don't need this. I need this. What does this do in C? Short and concise. Let's do all of these actually. What do these lines of code do in C? Short and concise, please. Okay, first one. We get the prompt and waits for user input, and okay, yeah, this is something that I was interested in. Why is it a pointer to a character? Stores the user input as a dynamically allocated string. Dynamically allocated string. This one adds to history, whatever this means. This one prints, and this freeze. Okay. Why is the input a pointer to a car? Because the real-line functions returns a pointer to a dynamically allocated string. Okay, my head is starting to hurt. So, why the input is a pointer to a character? The input is a pointer to a character because readline returns the method returns a pointer to a dynamically allocated string. The function reads an entire line of text from the user, allocates enough memory to hold this line plus a null terminator, and returns a pointer to this. Okay. So what I assume is happening here is we are typing something like I don't know, test, right? And what is happening is that we get a certain memory allocation, which is dynamically allocated, because we are not doing this ahead of time, so it's dynamically allocated. Is and null pointer, end of the line, and yeah, that's it. This function reads an entire line of text, allocates enough memory to hold this line plus a null terminator. Okay, the exact size of the user input is not known before, so the memory must be allocated dynamically at runtime. Yeah, and we also need to manually free the memory so we don't overflow it. That's why we put this guy here. Okay. Let's continue. Let me just see. What the fuck is this now? Okay. the C preprocessor. I can remove this. For such a small project, it might be okay that we have to provide operating system. Sorry. It seems, is my stream broken? Hopefully not. Please don't be broken. Okay, it's not broken. Oh. I get random timeouts on inside the YouTube studio. Okay. Okay. So this section deals with portability, basically saying that different operating systems might have different compiling steps, and in a perfect world, I wouldn't need to think about other operating systems, but we are not working and living in a perfect world. So we need to use something called a preprocessor. The preprocessor is a program that runs before the compiler. I didn't know this. It has a number of purposes and okay, of course. A command line, sorry. Comment is actually handled by the preprocessor first before it comes to the compiler, because we want these lines to be ignored when we compile our C code. Okay, something that I didn't know beforehand. Or we've been using it to include header files, giving us access to file. But isn't this a comment? A comment? No, this is a comment. Okay, I'm an idiot. So basically, the preprocessor is a program that runs before the compiler. It has a number of purposes. Any line that starts with this octothorpe character, which is a hash to you and me, is a preprocessor command. Basically, not the comment, because this is a comment in JavaScript. Is it in TypeScript? Yeah, it's in TypeScript. We've been using it to include header files. Yeah, this is why where it is used mostly. Oh, fuck me. If we are running Windows, we are going to let the preprocessor emit code with some fake read line and add history functions I prepared. Otherwise, we are going to include the headers from the edit line and use these. Fuck me. To declare what code to compile, to declare. So these are the preprocessor statements: if def, else, and then div. These are like an if function that happens before the code is compiled. Okay. Okay. So let's edit our Vim script. Well, our C script, sorry. Okay. Okay. Standard input output, standard library. If you are compiling on Windows, compile these functions. Oops. Windows. This. What the fuck is this doing? So when it comes to C, I believe that my last encounter with a C programming language was an Arduino script that I wrote for my master thesis, which was an RFT scanner uh, for a gym membership. So basically, you have like your RFID card, and you scan it on the Arduino scanner, and basically it lets you in. Or if you are someone new, it urges you to register in our gym. But yeah, since then I didn't use much C, to be honest. I remember I had a lot of trouble with the memory allocation, especially because I wanted to display a message on the Arduino display screen, which I assume is a 16 times 2 characters length. So yes, I would get overflows all the time. Okay. Otherwise. Else include readline. And if, and I think everything else should be the same. Character input, yeah, everything else is the same. What are the chances it won't compile? Okay, it did. I mean, I have no way of testing this on a Windows machine, but I'm gonna trust Daniel. I think we can rest assured everything will work properly. Also, I don't plan on converting to Windows anytime soon. Okay, so change the, sorry, oops. Let's just move back to the book. Change the prompt from Lisp to something of your choice. What the fuck? Give me red. Change the prompt. I don't need this. This is fairly simple. Change what is echoed back to the user. Change what is echoed back to the user. So I don't need this either. Add an extra message to the version and exit information. I don't even have these in my in my script. What does the n mean in those strings? I assume what it means is that it adds a new line. What other patterns can be used with printf? No idea. What happens when you press printf for... Okay. So we are all the way up into chapter 5, but before we start climbing this mountain, I just want to make sure that I understood all of these properly. So what does this do? So basically what this does, it's a preprocessor conditional in C and C++ to check if the Win32 macro is defined, which I assume is a way of checking for what operating system you are using. Yeah, this macro is automatically defined by the compiler when you are compiling your code on a Windows operating system. Okay, I don't need this. So if we are on Windows, we are doing all of this. Otherwise, okay, explain me the whole method. Explain me how this works. Short and concise, and maybe give an example. I learn best when given examples. Okay, so let's do it line by line. So we have a prompt, and we print this prompt to the standard output. In our case, this is the console or the terminal. Next we have fgets, which will read the input from the user into the buffer. Now this, we are allocating memory of this size +1. +1, why? I assume because of the null pointer, right? So we are allocating all of this, and then we are copying this into the buffer. And where have we defined the buffer? Ah, here. Okay, so we are copying whatever we entered into this buffer. Okay. No. And what is this guy doing? It replace the new line character at the end with a null terminator. Okay, what happens here if I pulled the good information from the last 1 hour of streaming? What I assume it happens here is that we have a new line character at the end, and we are replacing it with a null terminator, and we return copy. Okay, add history input. Okay, simple enough. Uh, 55 minutes. That's the time we took to finish this chapter. The next one is chapter 5, which deals with programming languages. I'll just take a quick walk around the apartment, and I'm back in a jiffy, and we'll continue doing this. So see you in maybe, I don't know, 1 minute. Okay, I'm back. Oh, my computer is fighting for its life. I mean, it's a gaming machine, so I think it. Oops. So I think it should be able to take a beating. And it is. I think it's fighting this pretty well. What's the name of this top? Is it top? So OBS. Yeah. Let me just check this. Yeah, so what do we have? We have OBS, we have Chrome. Yeah, OBS is taking like 50% of our CPU and 4% of our memory size. Okay. Okay. I won't beat you anymore, little computer. I'll try to be done with this chapter fairly quickly. I hope you won't hear the humming of the computer, because I set up a noise suppressing filter on the OBS. But if you do, I don't know. I apologize, and I'll find another solution for it. Okay, let's continue. A programming language. Okay. So in the 1950s, the linguist Noam Chomsky, and I think he's still alive. He must be like 100 years old now. Formalized a number of important observations. Okay, the cat walked on the carpet. Using the rules of English, the noun cat can be replaced by two nouns separated by and. Okay, I don't care about this very much. Okay. Oh, fuck me. Is my brain fried? I hope not. I hope not. uh, so, Chomsky had an observation. There is an infinite number of different things that can be said. Make sense? Or written down in a particular language, it's still possible to process and understand all of them with a finite number of rewrite rules. The name given to a set. Okay. So basically, what these really confusing sentences are trying to convey is that, let's say we have this paragraph. Although we can say whatever is said here in most probably an infinite amount of ways, we have certain rules that describe the rules of how this is written, and these rules are called the grammar, which I assume every programming language should have them as well. We can okay, one way is textual. We could say something like a sentence must be a verb phrase. A sentence must be a verb phrase. Or a verb phrase can be either a verb or an adverb and a verb. This method is good for humans. Okay. Yes. So, when dealing with computers, we need a more formal description of a grammar. Okay. To write a programming language such as our Lisp, we are going to need to understand grammars. For reading in the user input, we need to write a grammar which describes it. Okay, so what this basically does is, just tells us in order to create a programming language, we need a grammar. And that's everything, I assume. And for that, we are going to use this library called MPC. Okay. And what is MPC? MPC is a parser combinator. I have no idea how to say this. Library I have written. This means it is a library that allows you to build programs that understand and process particular languages. Okay. What is a parser? Combination library. Okay. So, what does code that looks like a grammar look like? Let us take a look at MPC by trying to write code for a grammar that recognizes the language of Shiba Inu. And what is the language of Shiba Inu? Okay. It's a meme from the antique period of the internet. Okay, so we have an now. I don't know how I passed the English language in my high school and university because, or even my mother tongue, because I have no idea how sentences are constructed. I have no idea of the conjugation of verbs, right? Basically, I'm using a language, but I'm really bad at recognizing how it works. So maybe I'll learn something interesting here. So we have an adjective. Okay, we have a noun, we have a phrase, and we have a dog. So a noun, an adjective is either wow, many, so, or such. A noun is noun. It's either Lisp, language, see, book, or build. So a phrase could be, according to this, it could be wow, book, right? And a dog is 0 or more phrases. So actually, this is a dog on its own. Oh, my computer is so hot. What chapter is this? Chapter 5, right? Yes. Oops, let me just move it back to this. Okay. We can start by trying to define adjective and noun. Noun. To do this, we create 2 new parsers represented by the type. Okay, so this comes from the library. Oh, fuck. I have no idea. Wait, I'm having trouble understanding this. So we create a parser. And I need to ask, what's a parser? Okay, let's do this again. So we are creating a parser adjective. So, and the parser is saying, okay, use one of these several options. MPC or, and why is this 4 here? 1, 2, 3. Okay, I assume it's the number of initial strings. Okay, so we are officially working with MPC in the next chapter. So we need to use the function MPC and that specifies one thing is required then another. Is this an A here? As input we pass adjective and noun. Oops. Yeah, so basically we just created a language here. So here are just some examples of possible strings dog could accept. Yeah. Okay. Let us maybe stop here. I think we have been learning for how much? An hour and 13 seconds. 13 minutes. Yeah, maybe let's stop here and continue tomorrow. Let me just see. MPC lets us write grammars in a more natural form too, rather than using C functions. Okay, my brain is fried. Basically, what I assume will happen now is that we're gonna create a grammar for our Lisp programming language. I don't think it should be that complex. I just need to brush up my knowledge on the parsers and on the library that we'll use in this course. Again, I don't think it will be that hard. We just need to understand it properly. We just need to understand how it works and, you know, use it, utilize it. I think it will be okay. So, thank you all for watching, if anyone is watching, and see you in the next episode. Bye bye.